Well, welcome to this first Mastery Practice Problems and Solutions sessions. This one is concerning being able to distinguish populations from samples and parameters from statistics. So you should have already taken out your workbook, which contains all of the questions that I'm going to solve here, and given your own answers. If you haven't done that yet, I think what I'll do is I'll pause, fade out after posing each question, give you a chance to answer it, come back and give the solution. I've only got 5 in this case. This won't take long. I'm just going to talk through the solutions. So let me move to the first slide. Again, we're talking about populations versus samples, parameters versus statistics. And on this first chart are the basic definitions. The population is the group or the data set that you wish to study. It has attributes, features, characteristics. Those are called parameters. So it's population parameters. Often we study these populations by pulling out what we hope is a representative sample, just a subset. Its attributes are called statistics. That's sort of the beginning and the end of this section, but I'll tell you, it's one of the more important things I think to learn this week, because throughout this course, most of the problems are presented to you as word problems. You have to read the problem and pull out the information. And in almost all cases, one of the first things you'll have to do is decide whether you're being given information about a population or are you being given information about a sample. Sounds simple. It's not always that simple. You know, I've said that, oh, by the way, in practice, you're always going to know what you're doing. But for students, some of these problems aren't written terribly well, and you might have to make some assumptions. Okay, and so, in fact, in these problems, I've tried to give you some examples that are both written in, I think, a very clear fashion and some that are not so clear. So let's take on this first question. First problem, identify the population of the sample. In this short scenario, a survey of 1,353 American households found that 18% of the households own a computer. Is that a population or is that a sample? Let me break for a second. Okay, we're back. You should find that the population is all the American households. The sample is 1,353 American households that were surveyed, and it's that word survey that gives it all away. A survey is a sampling technique. When you see words like a survey or a poll, you can be sure that a sample was taken. So to read it again, a survey of 1,353 American households, that's making reference to the sample. And then you ask, what is it that this sample is trying to study? You know, it's reasonable to say all American households. It's really as simple as that. I would call this a straightforward problem and solution. So let's go to problem 2. Problem 2 says identify the population of the sample. It says a recent survey by the alumni of a major university indicated that the average salary of the 10,000 of its 300,000 graduates was $125,000. Let me fade away again. Okay, we're back. And I'll tell you, I believe problem 2 is also straightforward. Again, there's that word survey. Survey indicates that a sample was taken. We just have to figure out where it was. A recent sample by the alumni of a major university indicated the average salary of 10,000. There's the sample. 10,000 of its graduates were surveyed. They're the sample. The question is, what's the population? The population is not so terribly clear. It could be the 300,000 graduates made reference to here. It could be all of the alumni. It's really, you really have to kind of have an open mind as to exactly what the population is. And when you run into a situation like this, if you can, you should answer it as I have. I think the best answer is probably 300,000 graduates. That's why it was stated in the problem. But it could be all alumni, and that's how I've indicated that. So we'll call that straightforward as well too, and we'll move to problem 3. Problem 3 says, identify the population in the sample. And the little scenario reads, a scientist takes a big bucket of water from a lake and counts how many species of bacteria, bugs, and other creepy crawlies he finds in the bucket. What's the population? What's the sample? I'll break again. All right, we're back. So in this case, I don't see a word survey. I don't see any specific sort of telltale smoking gun word, but we do have someone taking a bucket of water from a lake. It's not studying all of the animals and creepy crawlies within the lake. He's a big task, right? Instead, he's taking a bucket, a subset of that lake. So pretty clearly the bucket is the sample, or the creepy crawlies within the bucket are the samples, or it is the sample. And the population are the creepy crawlies within the lake. Bugs in the lake, bugs in the bucket. I'm going to call that straightforward as well too. But in problems 4 and 5 coming up, you'll start to see where some of these things get a little bit confusing. So let's look now at problem 4. Problem 4 again says, states the problem a little differently. It says, determine whether the underlying numerical value is a population parameter or a sample statistic. And if I just look down at the scenario statement, I see $33,000 numerical value underlined. So that's what we're supposed to focus on. And it says the average salary of all assembly line employees at a certain car manufacturer is $33,000. What is that? Is this a population parameter, $33,000, or is it a sample statistic? Take a second and try to answer that. So back again. So this one to me is not very clear, frankly. I don't even really know what was intended here. There are a number of possibilities. Perhaps this car manufacturer is truly interested in the average salary of just its assembly line workers. That's quite reasonable, I would say. In which case, $33,000 is a population parameter, and it was determined from what is called a census. A census is it's essentially a sampling of the entire population. It's when every element of the population is queried. There is in that case no sample statistics associated with it. So if it's the case that that car manufacturer is interested in the average salary of the assembly line workers, then the answer is that the population is the assembly line workers. There is no statistic. But it seems odd to me. It doesn't seem odd to me. It's just one possibility. It could also be, you have to read a little bit more into this, I think, that the average salary of all the assembly line workers was taken as part of a cluster sample or a stratified sample, perhaps, in which in an exercise in which the car manufacturer is trying to look at the average salary of all of its workers. In order to do that, it might very reasonably have stratified its workers or clustered its workers as assembly line workers, administrative workers, whatever the engineering department workers, whatever the other departments are. And achieved a random sampling through that method. If that was the case, then $33,000 would be a sample statistic, and the associated population parameter would be all of the employees at the car manufacturer. And that's how I've answered that. I've said first case, all assembly line employees at a certain car manufacturer, $33,000 is a population parameter, is the population parameter, and there's no sample statistic. Or the population parameter, all employees at a certain car manufacturer, that's the population, that is, and the assembly line workers are a cluster sample, $33,000 is a sample statistic. So if I just read that bottom line, in practice, again, I've said this earlier, you'll always be able to distinguish the population with the sample, but as a student, you're going to run across problems such as this that are not definitively stated. You run across them everywhere, just use your best judgment and, if possible, ask for clarifications. So, problem 4 is a problem that I would say was not particularly straightforward. And finally, here is problem 5. This problem is a little bit of a departure. I'm not asking you to identify a population or a sample or distinguish a population or sample. I'm just asking some questions about populations and samples, and I'm doing it in this way. Problem 5 says, which of the following statements are true? And statement 1 says, sample size is never bigger than population size. And 2, the population mean is a statistic. So take a moment. All right, let's take on 2 first. 2 says the population mean is a statistic, essentially true or false. The mean is an attribute or a characteristic, and if it's a characteristic of the population, it's a parameter, not a statistic. That's the basic definition that we're working on here. But one is a little bit more clever. 1 says sample size is never bigger than the population size, true or false. And even in these prior problems, we've seen a bucket taken out of a lake. We've seen 10,000 graduates taken out of 300,000. In a lot of cases, the sample is smaller, but it doesn't have to be. In fact, in the case in which you are doing draws on a population with replacement, you can just arbitrarily make the sample as large as you want. The easiest example I can show you is from a deck of cards. Population is 52 cards. Yeah. But suppose that I wanted to prove myself that the probability of drawing out a red card is 50%. How might I do that? I might take a draw, note whether this is red or black, put it back in. Okay, take another draw, note if this is red or black, maybe this is all red, put it back in. And I can keep doing that indefinitely. And as I do, actually, the measurement that I make, the number of red cards versus the number of black cards, will start to approach 50%. So yeah, it's the answer to this problem then is neither 1 nor 2 are true statements. All right, so that completes this little session. I've said before that what I'm trying to do in this practice problem is actually focus not on problems like this, but on problems which require solutions, calculations, and whatnot. And that's what you'll start seeing next week. All right, thanks a lot.